Good afternoon, good evening to everybody here. It truly is a pleasure to be able to give this speech today. When Ryan called me up, as he said, I was excited about this opportunity, and it was a really special invitation for me. Some of the reason for that he went through is because the Genomatica story, in essence, really started here. It started in this community. This technical field is where I got my start. This community of people, many of whom I spent a lot of time with, and in this conference as well. It's always been sort of a benchmark for me as far as how we've progressed as a company, and so it's wonderful to be here. I thought what I'd like to do is to start, since we're going to talk a bit about that journey. I was going to start with a story about Genomatica. This is a story that took place about 7 years ago. In fact, I was just asking Mark Burke if he knew this story, and I realized I had never shared this story with him, and most people at Genomatica didn't know this. About 7 years ago, Mark and I were out on the road. We were trying to raise capital to really transform Genomatica into the company that it is today. And at that point in time, we had talked to a number of different investors. The investment group that we wanted to have lead the opportunity in Genomatica, we agreed to some terms, and we were excited about that. The deal wasn't quite done yet, and I get a call from a guy who today is the chairman of our board, and he says to me, "Christophe, I have a very important question that I need to ask you, and this is for me, this is kind of the last step before we can move forward, and it's really important, and it's going to need to be a face-to-face conversation." And I'm down in San Diego, he's in San Francisco, so of course, get on a plane and I go to meet him. And you can imagine I'm going up there, and he's looking to write about a $20 million check to get us going on this business. I'm a little nervous about what he's going to ask, and I'm thinking, my gosh, what could this be? And we sit down and we have lunch. And he asked me the simplest, but yet the most important of questions. And he said to me, "I need to know if it's about the end point or if it's about the journey. And it's really simple, and it's one or the other. So tell me which one it is for you." And I thought, well, geez, this guy's going to put money in our company because he's looking to make money, and that's probably the end point. So maybe that's what I'm supposed to say. And but then I thought, for me, it really is about the journey. It's about the people. It's about the experiences. It's about building something. So what am I going to do? So I tell him it's about the journey. And I kind of swallowed my breath before I said it because I thought, man, maybe I'm going to say the wrong word. But right after I said it, he kind of reached over the hand and shook my hand and said, we have a deal. And let's go and build this thing. And so that story is something I'll come back to, but really a lot of what I'm going to talk about today is about a journey and about a lot of the wonderful things that happen along there. There's a lot of ups, there's a lot of downs, but we built this company into a great place, and I'm going to talk a little bit about that. So I've got 3 things I want to do in the 40 minutes or so that we have. I'm going to walk you through a bit of that journey, tell you about sort of the progression of that, some of the learnings that we had. I'm going to go through and talk about some of the things that I think were important decision points or areas of focus for Genomatica as we went through that journey. And then I'm also going to talk about, if we have some time, share some guiding principles. So the best place to start is, since there's a lot of people in this audience who perhaps may not know a lot about the history of Genomatica, what I want to do is kind of level set and say, well, where are we today? What is Genomatica today? To give you a sense of how then we got there. And so today, Genomatica is positioned itself as a partner for the chemical industry when it comes to biotechnology. We're about developing processes to convert alternative feedstocks into large volume commodity chemicals that already have multi-billion-dollar markets today in the chemical industry. And the way we help that industry out and the way we enable it is with technology that can deliver competitive cost positions or better economics and smaller environmental footprint. So quite simply, we just view it as it's just a better way to make chemicals. We focus on a range of different feedstocks that represent ways for the chemical industry to diversify away from crude oil. And we also focus on a range of downstream products that we'll talk about. These are the products that make up the world we live in. So we develop those technologies. We'll refer to them as advantaged technologies. It's built up around an integrated biotechnology platform I'll touch a little bit on today. There's going to be some other presentations that'll mention some about it. An extensive intellectual property portfolio, bring those together, and we develop these advantaged technologies. That platform is really based on 3 pillars. And the first, it speaks to the founding area of the company and the core competency around computational modeling of metabolism. And that's something that I would say what we used to do about 10 to 15 years ago in the early days of the company. We've sort of taken that to a whole nother level with what we do inside Genomatica and how we make that a key part of our platform, something I'll speak to a little later. The other is, of course, the experimental capabilities. So how do we, sometimes we like to say in a very simplistic sense, how do we bring the designs that we come up with in the computer, how do we bring those to life through the use of very focused, efficient, and sometimes high throughput experimental technologies. And then last but not least, process engineering is a critical component of what we do. And we'll get into how those things are all integrated and why they're so important. Now, as a company, we obviously have to make money. Our business model is what's referred to as a licensing business model in the industry. And so what that means is we develop the technology, and then we deliver that technology to commercial manufacturing companies. So think of the big chemical companies who actually build plants, and they operate those plants, and they own them. We deliver the technology. So we deliver not just the microorganism that makes a chemical, a complete process design, and all the know-how to help run that sort of facility. So that's what we deliver, and this is a business model that the chemical industry is very familiar with. In fact, many of the plants that you would see in the chemical industry are using technology that was developed by other companies who licensed that technology to them. So that's effectively how we make money, and in some cases, we have a number of technologies that we're trying to develop for various chemicals where companies will want to see those technologies developed in a more accelerated fashion, and they can work with us to sponsor some of the development of those technologies that they will ultimately commercialize. So that's our business model. Again, we deliver complete process design packages. So can't really see it terribly well, but a full process design together with the organism, together with the know-how to run and operate that plant. So this is what we deliver. Our first product, or our first process technology, is for a chemical butadiene. This is about a $4 billion a year global market, and we developed a process that we call the Genomatica process. Effectively, it's a microorganism that directly takes sugars and converts that into butadiene. And I'll talk more about that journey as we go forward. It's a process that we've now licensed to BASF, we've licensed to Novamont. There's close to now over 10 million pounds of this has been produced, and it's being sold today, and you'll find this product coming into downstream markets in a range of product applications, some of which I'll be able to speak to. So this is our first process. It's a technology that took us, we started about 5 years to go from concept to commercialization. I'll highlight that for you to give you a sense of what it took to get there. And from there, we're now building already onto a rapid start in our second product, which is process for making butadiene, which is a much larger market opportunity, about a $20 billion a year market opportunity. This is a technology that we're developing with a number of partners, in particular Versalis and Braskem. These are big names in the global chemical industry. They're very involved in the butadiene chain, either as producers or companies who convert butadiene into a range of downstream products. And we've developed a number of different routes to be able to produce butadiene, either directly in a microorganism or by going through an intermediate, 1,3-butanediol, as opposed to 1,4-butanediol, which is the global commodity. And we're off to a tremendous start on this. We've got substantial amount of research and development funding, and I believe on Wednesday, actually, Mark will be giving a presentation, and he's going to share some of the exciting results that we've already been able to achieve that show the power of the platform, that what we've done in BDO is now being able to be replicated for other chemicals. So it's a very exciting opportunity for us to see develop and the pace at which it's developing. We've been able to create really a top-tier set of partners to help us commercialize these technologies. And this has been part of the key to our success. A range of different global chemical companies either have helped us to develop technology, looking to build plants with this technology, or looking to take the chemicals that are produced from these technologies and turn them into downstream products that they already make today using conventionally produced chemicals. So with that in the story, we've also had the fortune of being able to attract significant investment dollars into the company. As I mentioned to you, we really started in 2007 in raising venture capital. The company has an earlier origin, which I'm going to share in a moment. But in 2007 was when we started raising capital. That Mark and I went out, $20 million is where it started with. That's grown now to about $125 million. We've got a great track record of delivering and growing shareholder value in the course of doing that. Some marquee investors, venture capital groups, strategic investors. It's a pretty broad, pretty distributed collection of investors, and we're very fortunate to have that. We've also been able to garner a good amount of recognition for the accomplishments that we have in a range of different areas. Some awards that we received have been for our technology platform, others for the work in BDO, some for industry leadership, and importantly also for our corporate culture, which I'll touch on as well. So some of these awards we received in 2011, the EPA Green Chemistry Award, which was of significance to us because we won this in an award that was for large companies, in essence. We were not the first company in industrial biotechnology to win this award, but we were the first small company to win it in a large company category for the potentially transformative abilities of these technologies that we're developing. So that was a great for us. We were excited. A Wall Street Journal Innovation Award. We were also voted one of the leading renewable chemical companies for a couple of years. And importantly, though, we recently received an award that I wanted to highlight because really, to me, this is an award about this entire field and not about Genomatica. We received an award called the Kirkpatrick Award, which is given out by really the chemical industry for the most noteworthy developments in the past 2 years. Most noteworthy chemical engineering technology to be commercialized. It's not a biotechnology, just a chemical engineering technology. Just so happened that we won that award based on industrial biotechnology, based on the power of what biology and microorganisms can do. That's what we were able to accomplish. I hope to see a lot more companies in this field be able to win these types of awards as we are all collectively helping to try and transform the global chemical industry with these technologies. So that's what Genomatica looks like today. We have built ourselves into a commercial innovator in this field of industrial biotechnology. Our first product is commercial. Our second one's off to a fast start. We've got a number of other exciting technologies under development that you'll be hearing us talk about in the near future on other chemicals, as well as unlocking the door to other important feedstock opportunities. And we're really excited about being able to roll those stories out in the next couple of years to share with you what's happening. We're a little over 100 people at Genomatica. Probably about 80 of those people are focused on research and development and process engineering. So we're really a technical innovation house is really what we're built around. So that's Genomatica today. I was asked to give the story of how we got here, really. But that sets the stage for where we are today. And so as I wanted to think about telling you the rest of the story, how we got here, I thought, the most important place for me to start is actually something that is really the most sacred slide that we have at Genomatica, in essence, if I was to share this with you. This is our core purpose or our core values. And the reason why I put this up is, a lot of companies have values that they write up. You can go to a website. We live these. And this, I'll tell you right here, is probably one of the most single important factors that has determined our success as a company. And our core purpose is stated up there, and I'll read it for you. It's to lead the irresistible transition to sustainable materials through our technology, and united with industry leaders, make our world a better place. So everybody comes to Genomatica and they come to work or they come to partner with us. This is kind of what you're signed up for. This is what we believe in. And more importantly is our value system. So if I was to tell you Genomatica was a person, and you were going to describe that person with a couple of adjectives, they would be our core values. And so we say that we're real, we are innovative, and we're united, and we're relentless. And those are the 4 values that I think will characterize all the actions that we take and how we go about doing our business, both internally and with partners, as well as our external voice to the industry and to our stakeholders. So this is important. And this brings me to kind of the first of a series of key aspects that are either decision points we made or areas of emphasis and focus in our company that are critical. So the first one here is really about values. It's about living our core values and why this is so important. It's hard to understand this unless you're in companies that either have this or don't have this, how important it is. It's a crucial thing. We talk a lot about organizational health and values-based leadership, and for those that are interested, there's a great book that talks about this. It's called The Advantage, and it's why organizational health trumps everything in business. So it's important. But there's a lot more to this story. So let me tell you a little bit about how we got here. Ryan mentioned that about 18 years ago, I was sitting in this audience like many of you. I was a student. I was in Bernard Paulson's lab at UCSD. I was getting my PhD, and at that time, the term was systems biology, genome scale models, and so this was the area that I was focused in on. And then in 1998, together with Bernard, we incorporated Genomatica. Now, I was still a graduate student, so effectively waited until 2000 to start operations, which was also right around when I graduated. Got my PhD, started the company. And Genomatica's history really has 2 chapters to it. The first goes from 2000 to 2007, where we were a company that was focused on these technologies around metabolism, computational tools. We were exclusively computational modeling. There's a number of people in this audience who were employees at Genomatica at that time. Some of them are still employees at Genomatica. Some have moved on to do other great things. So there's a number of people here who experienced those early days. It set the foundation for us that ultimately led to a key decision that we made in late 2006 that ultimately consummated in 2007, where we focused Genomatica on what some might say vertically integrating instead of just computational technologies, adding all the experimental capabilities and adding the process engineering and building the company that I just described. At that time, we also spun off a company that I'll share just a bit about as well called GT Life Sciences that was to focus in areas outside of chemicals. And that went on to successfully be acquired about 3 years ago in a transaction that was terrific for the early investors in Genomatica. And then since then, we've been able to build the Genomatica story as I described earlier. So this is the path that we went down, and it was a journey, and it still is a journey, and it's still being written today, of course. So just real briefly, UCSD, Bernard's lab, doing my PhD on things like what was called at the time, we called them extreme pathways and convex analysis, looking at metabolic networks and systems. And so I dug up some old slides from my PhD thesis, and they look kind of like this, some interesting equations up there, metabolic networks that I'm sure you guys have all seen before. We built genome scale models of organisms like Helicobacter pylori, Haemophilus influenza, developed interesting tools to query those networks. What would happen if you knocked out genes? What would happen if you changed the substrates that were provided to these organisms under different types of genetic profiles? What would happen in a range of scenarios? So this was really what I was doing, and this is probably what most people in 2000 knew that I did. I was very much technically focused. I was getting my PhD, and here we were. And then all of a sudden, up pops this company, Genomatica. So, how did that happen? Is really the start, I think, of this question. I grew up in a very entrepreneurial family. My father and my mother came over from Europe. My father was German and my mother's French. And we won't tell my father that I'm wearing a French jersey today for the France victory in the World Cup today. But anyhow, I grew up in an entrepreneurial home. I was the first one in my family to go get a college degree. And I happened to also be the kid that was really interested in science and engineering. And so here I found myself getting a PhD. But I didn't know what it was like to go work at a big company. And I didn't really know what it was like to be a professor. But what I did know was starting a business. And it sounds kind of funny, but really that's what I felt comfortable doing. And there was an opportunity, there was technology there, and I thought we could create value around it. So I told Bernard, I said, let's start this company. Fortunately, he had experience in starting a number of biotechnology companies, both private and some that were public. And I really found, fortunately, a perfect match to support my, I would say, young entrepreneurial ambitions. And so back in 2000, that's what it looked like. There we launched off to go build the company. And so the early chapter of Genomatica is one that was built around trying to apply computational modeling of metabolism to just about any area where we could find that it would add value. And so this was an old slide that I dug up. We were founded again in 2000. We had gone from 2000 to 2007, just to give you a sense of this. We started in 2000 and we raised about $3 million in investments, primarily from what you would call angel investors, so not professional venture capital. And they were very patient, fortunately, because I was pretty young. And it allowed, again, me to have an environment where I could grow as well as the company, and we could ultimately find where our true value would be. Over the course of that time, we were able to establish partnerships with a number of great companies and try to help out in processes where they were using microorganisms in fermentation to produce products, or in some cases in applications that were related to metabolism, where they were trying to understand how microorganisms and their metabolism led to certain either disease conditions or things around personal care products and so forth. We had produced over that 7-year period, we generated about $20 million in revenue, and we were about 20 plus people. We were slightly cash flow positive business, and probably what you would call an interesting lifestyle sort of business at the most. Didn't have great growth prospects, but there were some interesting technology we were developing and interesting IP we were creating. So we kind of got to this point in 2006 where we thought, this is interesting. We're sort of more like a consulting services for research. But we just felt inherently that there was a lot more that we could do with this technology than what we were doing. And so the question was, how did we figure that out? How do we figure out where to go? And so the first thing that we had done was we ended up going through an exercise to look at all the different areas that we were applying the technology. And there's a range of about 5 of them that are listed here. And what I'll tell you is a company of 20 people can't do these. You can't do all of this. You can probably at best do one. And we kind of learned, I would say, the hard way or the long way, a phrase that a lot of people use, which is we felt like in a way we were the jack of all trades and the master of none, right? So how are we going to figure out really how to apply this technology in a more focused manner to build value? So we ultimately ended up picking really the first one, which is around fermentation for chemicals, and I'll tell you more about that in a moment. But one of the good things that came out of that period of time was that we did develop a software system that we called Symphony. And for the companies that worked with us, and there were certain select academic labs as well that we had an access program with, they had access to this tool. They had access to these technologies. It was basically a professional grade system for building genome scale models of metabolism, managing that information, continuing to build them based on new insights, new experimental data, and asking questions, coming up with hypotheses, being able to then go in the lab and test them. So we developed this system. It turned out to be a really useful tool for us, and in some cases, some of the partners who we had it were able to use it as well. The challenge was that it was an expert system, okay? The people that know how to use this system probably are only going to be found in this room. And even in this room, there's probably only a handful of people that really use these systems and use them extensively and effectively. So if you're trying to build a software business, that's not a really big market. So software, even though we built it because we needed to do our research, wasn't going to be really an end product for us. Today, we still use this system. We use it in-house. We actually don't license it out to people. We don't provide that out as a tool, generally speaking. Again, it comes down to focus for us. So really the second key point I wanted to mention was this Symphony. The decision to build this, and at that time it was around the rise of bioinformatics. One of the decisions that we did as well, we said, we're not going to hire, quote, bioinformatics people to build this. We hired a professional software team, and they built a tool that people could use. It was sort of a user-friendly tool to help do the science. That was important for us. The reason why it was important was not just the early partnerships that it helped us to generate, but actually what it helps even today is it was really the start of indoctrinating a computational mindset into the company and being able to develop a suite of tools that today is very unique in the industry. We built off from Symphony to add a range of discovery tools, pathway tools that we can figure out all the ways to make a chemical biologically. More importantly, we built a system that we call Symphony Lab that allows us to manage all of our experimental data, integrate that with the modeling and the analysis, and become an incredibly powerful tool. This would generally fall in the category of what some people call a LIMS system, or a laboratory information management system. Very powerful capability for us that's unique, it's customized, and it's user-friendly, right? And that's all started from the basis of Symphony that we established. It's part of what underpins our approach of systems-based metabolic engineering. That approach is critical to making BDO a success and critical for what we're doing going forward. Some of these things and some of those successes are what Mark will talk a little bit about on Wednesday and share more on that. So Symphony was in place, interesting little business. We're getting ready to change, and we decided to change and focus on chemicals. So what had changed externally for us was the world of energy. And why was this not an opportunity in 2000? Quite simply, if you look at the price of oil, if you look at the price of energy, things had changed dramatically from 2000 to 2007. Oil had probably tripled in price, and people were talking about things like energy security and so on and so forth. So from there, we ended up focusing in on chemicals. We saw that there were some forces in the area of industrial biotechnology that were interesting. There was always an undercurrent that people wanted to see more environmentally derived or more environmentally sustainable products. So there was a lot of good stories and sort of goodness in here that we thought this seemed like an area that we could focus in on, and one where the modeling technology itself could be critical to the successful product. I'll give you the corollary to that. One of the areas where we thought we could develop this technology would be to identify targets in metabolism in, let's say, an infectious organism, that if you block that target, the organism would not be able to grow. And that would become a good target for an anti-infective therapeutic. Well, if you play that out, and if it was successful, what would happen is then you'd have to find a molecule that hits that target, and that molecule is what's valuable, not the target itself. So even though the modeling would be useful in finding a valuable outcome, it wouldn't be what would derive the most value. Whereas here, we felt that what was really going to be valuable was how we would engineer organisms. Those designs, making that happen, turning high-producing organisms into these factories, so to speak, that's what would get us the most value. So we decided to focus in on chemicals. This is a classic price to volume curve of molecules that you can make. When you look at very large volumes but very low value, that's a fuel. When you go to very small volumes, very high value, that's a pharmaceutical product. So we looked there, and what we found was what we felt was a real sweet spot in the middle, and it's what I'll call the core molecules of the chemical industry. Basic and intermediate chemicals, there's probably about 30 to 40 of these. They all have market sizes that range from, I would say, about a couple $1 billion, and in some extreme cases, even looking at about $100 billion. They're very large, and the price points we thought were attainable using biology. All right, now we had to figure out how to be selective within those, and that was a whole nother exercise. But we had committed ourselves that we were not going to pursue fuels. We didn't think that that was a smart way to go. We also weren't going to pursue platform molecules. And there's a lot of them that were talked about at that time and still are today. The challenge for a business is there's really no market. There's a lot of molecules that people say it could grow into a huge market. Well, for a small company, you don't have time to wait for those markets to develop, and it takes typically 10 to 20 years to develop those markets. So we chose to go after existing chemicals with large existing markets. And that meant we were going to have to develop technology that could produce those chemicals at a better cost position than how they're made today or at that time. So that's the next key point for us, was to target chemicals exclusively. That helped us to focus the company, and at the same time, that then led to spinning off this GT Life Sciences. Now, what was key into that was we needed to have a lot more capabilities and really technology leadership than what we had. We were going to get ready to embark on an area. We were adding experimental capabilities, process engineering, a whole lot of stuff. And I guess I would probably say that the thing that I maybe knew was that I didn't know a lot of that stuff really, really well. I was fortunate to escape out of grad school without doing a lot of experimental work. I'd done some as an undergrad, but here I was. And so really very fortunate to have crossed paths with Mark, one of the most passionate technologists I know of, and really has been a perfect match from my standpoint for us to help build this company together. Mark brought tremendous experience on the chemistry as well as enzyme development from his prior career, and now he was bringing that into the world of metabolism. And I don't think, Mark, you're over there, you probably weren't thinking too much about metabolic engineering prior to those days until joining Genomatica. And so, at the time, we sent Mark on a crash course in metabolism. We actually sent him to this conference. Back in 2006, Mark joined us here. Tony Bergard, who's in the audience, and Iman as well. This was a shot of Mark in Amsterdam at his first Metabolic Engineering Conference. So there we were. We'd now basically launched Genomatica that most people know of today. We were going to focus in on chemicals. And because we wanted to focus, we took the application of all that computational modeling as it applied to medical applications primarily, and we sort of put that into another company. We spun that out, and that was called GT for Genomatica, GT Life Sciences. And that company then ended up going on, here as I'll show you in a minute, to do some interesting things as well. In Genomatica, we then raised $20 million, starting with the story that I told you at the beginning about our investor and the journey and the endpoint. So that really then launched us into the Genomatica that most people know today. Now, as I said, we spun off a company, and so part of that, which was good, I would say, was that Iman, who worked for us, was really passionate about the field of applying computational models to more medical applications. And so she really wanted to pursue GT Life Sciences, so unfortunately that meant we had to say goodbye. So this is a picture of Iman on her last day before she ventured off into GT Life Sciences to turn that into a success. And I won't go into a lot of details on that. You could talk to Iman, she can tell you a lot more. I got to see it front row, front seat unfold as a member of the board of directors, and we also housed this company in Genomatica. But bottom line was they were able over a number of years to continue the approach that the early Genomatica had followed, focusing on the computational aspects, and ultimately built a company that was able to be acquired in a very positive transaction by Intrexon, which today is a multi-billion-dollar public company in the area of life sciences. So that brings us to Genomatica, and here we are now off to go build the company that I talked about at the beginning. We had a couple of things now what I'm going to focus on, and right around this time there are a couple of key decisions that were critical for our success. One of those was that we wanted to develop a portfolio of technologies. We weren't just going to develop, for instance, a process to make BDO. We knew we had a platform that could make technologies for a lot of different chemicals. We knew we wanted to pursue those. We wanted to sort of unleash the value of that platform. We also knew that while we wanted to pursue carbohydrate feedstocks primarily, we also looked at it and said, well, what could upset this story for us? There were scenarios where we could envision that oil prices could drop significantly, sugar prices could go up, and all of a sudden our business proposition wouldn't look so good. But really, we weren't experts necessarily in renewable feedstocks. We felt we wanted to be experts in the use of biotechnology to convert feedstocks into chemicals. So we also focused on the idea of laying out the blueprints for a strategy that would see us also develop in time technology to use C1 feedstocks, fermentable C1s, and turn that into chemicals. So this was all in 2007 and 2008. We laid out this type of a strategy. Feedstock flexibility was the key. We also knew, as I had mentioned early on, we were going to develop complete process technology. So we weren't just going to engineer organisms because we thought that ultimately that wouldn't be able to generate the kind of value that we felt we needed. So that meant we had to go from just having metabolic modeling to not only having the experimental capabilities, but ultimately adding the process engineering. So, now we venture off and we got into the world of experimental research. This is another one of our colleagues, Steve Van Dien, who many of you know. Actually, I met Steve at the Metabolic Engineering Conference in Il Ciocco, Italy in 2002, and started to recruit him back then. He joined us about a year or two later. Steve actually went on to lead the BDO project for the first probably 3 or 4 years within Genomatica. And now he's going on and he's one of our leaders in the butadiene technology development activities as well. Process engineering was a whole other area we had to develop. And once we put those together, we had to integrate them into a platform that ultimately could deliver these technologies. So we then had to figure out what our business model was going to be. This was a whole other thing. And the only reason I bring this up is there are a lot of companies in this field that have a very different business model than Genomatica. We aim to license technology. So we looked at either building your own plant or licensing technology to build plants. We focused in on licensing. We thought that was going to be the best approach for reasons that I'd be happy to explain, to get into. But bottom line is it would allow us to exploit our platform more effectively. It would require a lot less capital because we wouldn't have to build plants. And if we wanted to become the BDO producing company, that's pretty much all we would do. We wouldn't be able to develop technologies for other chemicals, and we would have felt that there was a lot of technology opportunity that would have been lost. So that's why we focused on a licensing model. This was another critical point in our journey. Again, we had to build complete capabilities to deliver process technologies, to do that in an integrated fashion, targeting many chemicals, and then also realizing that we were not going to build our own plants. And then we also had to decide, great, so were we going to suffer the same problem of becoming this sort of jack of all trades and the master of none? Were we going to pursue lots of different chemicals at the same time and maybe not be able to get one across the finish line? So quite simplistically, if I was to illustrate this, you'll see up here, the challenge was if I gave you 4 chemicals that you could produce and I gave you a certain budget to do it, would you pursue one of them maybe as your primary one, the other is the secondary and the third, or would you pick one and be able to pursue that, make it work, and then come back to the others? That's the right way to go, so long as you could preserve the opportunity to come back to the others, right? So you need to have the sort of intellectual property positions to do that. We actually believe that we could create those based on the computational tools we had and some of the experimental capabilities we had, and that was our strategy. So we were going to focus all our energies on BDO. We were going to make that a success. We felt that that would then create credibility for Genomatica in the industry. And from there, we could then leverage to go pursue other products. That's what we followed, and I think for the most part, that has been successful so far to date. We picked BDO as the first product because we thought that this could be both an interesting market opportunity, and it was sort of, I guess the easiest way to describe it is we felt that if we were successful, it was going to highlight the power of our technology platform. It was going to be sort of a technical tour de force. I think I was actually at a conference here in 2008, and I gave a presentation, and somebody had asked me in the audience, they just thought, you probably can't make this work, right? I don't see how the energetics work. It's not going to be possible. That was a common theme that we had heard in 2007, 2008, which just kind of emboldened us even more to make it work, because when we did, we knew we'd have a great story to be able to tell. We've gone on to build a very robust intellectual property portfolio. We've got over 500 plus, it's close to 600 now, issued and pending patent applications. We've issued patents on probably about 7 or 8 different major high-volume chemical targets. We think they're some of the most attractive routes to make those. We've talked publicly about BDO and butadiene, and I think you'll see stories come out in the future as we move forward here over the next year or two on some other chemical targets that we're also pursuing of high interest. And so we then went from this world of 2006 to the world of today. Oil prices continue to be high. That's a positive for us. At the same time, natural gas prices have plummeted. And in many cases, that's challenged industrial biotechnology. That's created a real difficult situation depending on what products you're going after. This has been problematic to a certain extent as well for certain fuel applications too. But for us, we were a little fortunate. When we built our portfolio in 2007 and 2008, we were concerned about, if you picked up a magazine in the chemical industry at that time, it was all about capacity expansion in the Middle East using natural gas, and that was going to produce chemicals at a very low cost. So we always targeted chemicals that were not normally produced conventionally from gas-based feedstocks, and that's put us in a very good position today. We had no idea what was going to happen with shale gas in North America, the knock-on effect to that globally, but we're in a pretty good position as a result of that nonetheless. Our butadiene story is highly motivated by what's happening in the gas situation in North America and the knock-on effect throughout the world. So that focus on BDO was critical. It established our credibility, gave us the ability then to prove our platform, and in parallel, invest in all that IP. And that would form the foundation of what we would go on to build. So from there, the rest is a story that perhaps some of you have seen us. We've spoken a lot about this, our journey for BDO. We went from the designs for the microorganisms to figuring out how to engineer these. We then went into the lab, created the first BDO producing organism. So no organism in the world made 1,4 BDO from sugars. We made that happen, and it took us probably about, I think about 4 or 5 months. And then from there, moved on to designing a full process design to be able to ultimately make polymer grade BDO that could be used to make all kinds of downstream polymers at the right purity, at the right quality levels. We then took that into a pilot facility in 2010 together with Michigan Biotech Institute, where we did some what I would call non-integrated pilot studies, fermentation scales of right around 3,000 liters, showing how our organisms would work, and then also various other downstream unit operations in a non-integrated fashion. And then in 2011, we went into an integrated demonstration facility. This is about producing 1 ton per week of product, and it was done in partnership with Tate & Lyle. There was a great facility that was used prior to demonstrate a process for making 1,3-propanediol that was a great technical success from DuPont and Tate & Lyle. And today there's a commercial plant that produces 1,3-propanediol, about a 70,000 ton per year facility. So along the way, while we were going through these scale-ups, we were improving our organism, continuously demonstrating improvements to that organism, demonstrating that its performance would work the same at lab scale, at demonstration scale, and ultimately at commercial scale, a crucial aspect. And I know in the workshop that Jeff Levency and Alex Batiste are going to give together, I think with Seth Heinen as well, on Thursday, they'll talk about a lot of these scale-up aspects and how critically important they are when you're doing lab scale research and development to understand these things. We then started shipping out tons of BDO, providing it to a range of companies that would qualify that BDO worked in downstream applications, and ultimately had a series of press releases last year that were very exciting, all with $10 billion plus chemical companies showing that BDO works in downstream applications like polymers like PBT, or ultimately in PTMEG, which is used for spandex, for instance, one of the largest volume applications of BDO. We even have a very exciting, there's a company up there, Far Eastern, which perhaps many people don't know. It's one of the world's largest polyester makers. They have a material that's comprised of probably on the order of about 30 to 40% BDO that has really attractive cooling properties. So when you're exercising, it'll actually keep that temperature of that shirt about 5 to 10 degrees cooler when you're exercising. It's garnering a lot of interest from companies like Nike or Adidas and so forth. So a lot of really interesting applications. And they're interested because it can now be 30 to 40% renewable. So another exciting story there. Right around that time, we also were fortunate to attract and recruit Jeff Levency, who's going to be here. He'll be here, I think, on Tuesday, and going through the workshop with you as well. Many people in this audience knew Jeff. Jeff had been one of the key people in developing 1,3-propanediol with DuPont and Tate & Lyle when he was at Tate & Lyle. He came to work with us, and he couldn't have come at a better time because we had just started to enter into a program where we were going to test our process at commercial scale in the plant that was designed to make 1,3-propanediol, but the design was sufficiently close that we could use it to make 1,4-butanediol, and DuPont Tate & Lyle had an opportunity that we could take advantage to slot in during some downtime. We were able to do that. We announced this about a little over a year ago, the success that was accomplished there. And this was a very significant event again for this industry. We had produced over 5 million pounds of BDO. So how much is that? Well, to give you a sense, over 120 tanker trucks of BDO in a 5-week period that was produced. Very substantial amount of product. We are actually able to sell all that product even at a positive margin. So it said something about the economics of how we were able to produce BDO. Recently we've shared some of the results from that. Jeff may be able to share more about this on Thursday. Very robust performance, continuous operation of a process for many, many weeks, and really led to a wonderful outcome for us and the ability to drive and show continued improvements to drive costs down over time. So a terrific success. Give you a sense of how much material that was. Oftentimes there's other peers that we have in this industry that are public companies, and they publish data on how much product is produced. In 2012, we were able to produce more material than any other company of our peer group, public or private, to produce BDO. I think if you saw numbers for 2013, they would look very similar. Part of the attractiveness is about cost. So all the wonderful science that we do, all the facts that it might be renewable, all of that at the end of the day comes down to what does it cost to make the chemical? And I think one of the real challenges is to take wonderful science and talking about things like pathways and enzymes and rates and titers and yields, and ultimately we take all of that and boil it down to a cost. Cents per pound, dollars per ton. That's what really matters at the end of the day. We've been able to deliver a technology that's cost competitive today with conventional petrochemical ways to make BDO. When somebody wants to go build a plant with our technology, it costs half the amount of capital that would cost to build that same capacity with a petrochemical process. So this is an example of what biotechnology can do. This is an example of what this field can do. And these are the advantages at the end of the day that it boils down to making those a success. Now, a key thing is being able to focus on cost. The topic on Thursday, that the workshop is going to focus a lot on this. This is a huge part of what we do. It's part of what it's kind of indoctrinated into our thinking. And it's really a framework for guiding R&D decisions. So imagine all the way back in the lab, decisions are made to engineer strains a certain way based on what our cost projections are all the way downstream. Not just for the fermentation, but every unit operation that goes through there. And that's critical to our success. So that then brings us to how we monitor that. Jeff will talk to you about some things like dashboards that allow us to ask all kinds of questions on how we benchmark our performance. And that sort of relentless focus on cost position has been crucial. That's been really important for what we do. And so oftentimes I hate to boil down wonderful, magnificent science into something that's so simple as just cost, but that's what really matters at the end of the day in this business. So hopefully those have given you a couple of insights into what makes us tick and how we got there, so to speak. And so from there, really just wanted to highlight a couple things. So where this technology is today, we've licensed technology to Novamont, building a commercial plant in Italy that we expect to come online towards probably the end of next year. We've also licensed the technology to BASF. They are the global leader in BDO, about a 30% market share or so. It's about a $1.5 billion a year business for BASF. They've licensed our technology. They came out with an announcement in November that they're now essentially open for business. Companies can buy BDO using the BDO process from BASF, and this is finding its way into the marketplace. There was recently an announcement a couple weeks back from Invista, the world's largest spandex provider, that you can buy bio-based spandex from Invista using BDO coming from this technology. So that's been the Genomatica story. And this is part of what's helped to get us here. We think we're in a very unique position going forward. We're excited about what we've accomplished, but the journey, so to speak, is never over. And we like where we're well positioned going forward in the industry. There's a lot of trends that continue that are important about demand for green products in the industry. It will be driven by the ability to deliver cost-effective technologies, and that's what we're focused on. Opportunities in different feedstocks, opportunities in different products. There's a range of things that are available and attractive out there. In general, I think the industry is in a very good position, and we're starting to see the seeds of transformation occur, not just by what we're doing, but by a lot of other companies based on a lot of technology that starts in places like this. So we're excited about that. I'll tell you, there's only one concern I have, and I just wanted to take a moment to highlight this for this community. Probably about 7 years ago, I think I remember Mark and I having a conversation when we first heard the term synthetic biology, and we thought, that's an interesting term, but the connotations of that could be potentially very negative. This crowd always used the term, at least metabolic engineering for the most part. That was always the term I knew of. And people started to use synthetic biology. So why is this important? I wanted to highlight something in case people didn't realize this. So a couple of weeks ago, actually, in fact, I think it was only about 2 weeks ago, many of you may know a company called Method. There's a company called Ecover, or Ecover. These are companies that you can go to Whole Foods, you can go to grocery stores, you can go to even Target, and you can go buy these products, and they are environmentally friendly. And those companies happen to be incorporating into some of those products oils or surfactants, for instance, that can come from technologies like those that Solazyme are developing. Okay, so Solazyme has genetically engineered algae, and it takes in sugar and it makes certain types of oils. They're doing metabolic engineering, and they're making products in fermentation tanks. And what happened here is there's a note, and you can maybe read some of this. If not, you can just look it up. If you look up Method, Ecover, and probably synthetic biology, you'll find it. It's an open letter from 17 non-governmental organizations, basically calling on them to quit using products made from synthetic biology because of the extreme science that it represents, the extreme unknowns that it represents. I'm going to tell you, I think that it's largely because of simply the use of that word and what has come about of that. And there's some great scientific opportunities that I would call synthetic biology. I'm not sure that's really what metabolic engineering was always designed to do. So this is a bit of a concern. I'm together with a couple of people. I know Sang Yup's here, are on the World Economic Forum, has a global council on biotechnology. It's concerned about these types of things. Big impact in the agricultural world around genetically modified organisms. Most of us would say, well, it's very different than a genetically modified microbe, right, that goes in a fermentation tank. That's not what these people are saying. And so, perception is reality in this kind of a field. So I just wanted to call attention to that as something that's a bit of a concern that's happening in the field. So with that, I think I'm pretty much done with what I wanted to share. If I've got a minute or two, I was just going to share some just guiding principles. So Ryan, you tell me how we're doing on time. We okay? All right. So in general, I took a step back to tell you this is one of my favorite books in sort of business. It's not a detailed business book. It's actually a good book, I think, for anybody to read. It's called Good to Great. And what is it that makes some companies great and some good? And there's a concept in there that asks 3 important questions. And great companies know the answer to these 3 questions. First one, as you see up there, it says, what are you deeply passionate about? That's one question. And the second one is, what you can be the best in the world at. Basically, what do you believe you can be the best in the world at? And then third is, what is it that drives your economic engine? So these are important things that guide us. I think when I look back at Genomatica, there's a lot of wonderful people that are involved, amazing people. If there's one thing that we have in common, we're passionate about the science. We're passionate about the technology. So I think we know what we're passionate about. When I put up that mission statement that I told you about, that's what we're passionate about. And the other thing is that we do believe that we can be the best in applying biology to make chemicals. Now, whether we are the best doesn't matter. We believe we can be the best, and that's what drives us forward. And we also understand what is the driver of our economic engine. And so I wanted to end with a quote here, and then just a little bit more on that story I started off with. This is a quote that I love. It's from Vince Lombardi, and it says, "We will chase perfection, and we'll chase it relentlessly." This is a football coach, by the way, for those that don't know. Knowing all the while that we can never attain it, but along the way, we shall catch excellence. Right? So I tend to be a perfectionist. I love this quote because I know I'll never attain perfection, but we strive for excellence, and I think that passion and that belief is really critical in whatever you do, And so for us, some of the guiding principles that can help you, whether it's that you're going to start a company, whether you're going to go work at a company, start your own lab, whatever it is, people is the most important thing in my mind, right? You gotta build great teams, and you gotta put people first and the team first. That's one thing we've had tremendous success with. Working with great people makes all the difference. Playing to your strengths is another thing that's important. We knew what we were good at, and I think we knew what we were not good at. I can tell you right now, we're not a company that builds plants. We don't operate world-scale manufacturing facilities. Could we hire those people and try to create that? Yeah, we could, but it's going to take a lot. We knew what we were really good at, and we stuck to that. Once we found the right focus, and we made sure we were sort of laser-focused, that's when great things happened for us. I mentioned already the collective passion and the belief. That's critical. So the last thing I'll say is what I really ended, or what I started with, which was around the whole concept of it's about the journey and not the end point. And so to end that, I had an interesting thing happen yesterday. So I was putting this talk together, and I realized I never asked that investor, our chairman of the board, why he asked me that question. Why did he ask me that? Even though I answered it the right way, what was he getting at? Why would anybody ask any of you that question? Why would it be about the end point or the journey? What is the significance of that, right? And I'm sure everybody can go off and think right now about whether it's the end point of the journey in whatever you're doing, right? So I asked him why he asked me that question, and he wrote me an email that had just an immense amount of great stuff in it. And I was just going to read one or two things from this, because he said to me, he said, "I was testing to see if you wanted to simply make money, the end point, or if you wanted to build an important company and make money as a byproduct." He said, "I find almost without exception that the former leads to a result that fails far short of expectation, or falls far short of expectation. And the latter requires you to focus on the journey and the impact that it'll have on employees, investors, customers, and partners along the way." He then went on to say that to focus on a journey requires a village. which is always a great statement. And I think what you saw here at Genomatica is absolutely about that. It requires a village. You can't do it alone. And if your sole focus is on an endpoint, then relationships don't matter, right? The endpoint matters. And if that's what you're trying to go for, I think in essence his message was, go for it, just I don't want to be a part of it. And so I think that's important. And the easiest way to remember this is that really there's a fallacy about the endpoint, which is that there is an endpoint. And it really isn't. Any business like Genomatica is really just a chapter in a long story that will continue on and on. And hopefully what we've been able to share here today about the Genomatica journey maybe can help a little bit in the journey that you all are on, whatever that may be and wherever that takes you. So thank you very much for all the time, all the attention, and I appreciate it. Thank you very much.